Hello, this is Keith Graham from Codasip. I'd like to talk to you about addressing memory from an assembly program as well as the memory view that you'll find in Codasip Studio's debugger. Now let's take a look at the store and load operations in assembly language because that will help us understand what we need to write in an assembly program. Now if we take a look at the store, we are going to take the value out of the RS2 register and store it at the memory location defined by the value in RS1 plus the immediate. And similar, for a load, we're going to read the value out of memory defined by the value in RS1 and the immediate and bring that into the register RS2. The key thing we need to remember, though, is that the immediate is signed, so it could be plus or minus a particular value. Now let's first take a look in my debugger here, how to build up a 32-bit word. Now, what we're going to show you here is 4 operations to build up a 32-bit value or store a 32-bit immediate. I have these comments, and this is what's showing the register location after this operation is completed. You can see that I've completed the line on 43. So the 321 is in the upper 20 bits of register 10. And then I'm going to shift it over to the right, so it's now in the lower 12 bits. Now I'm going to bring the next 20 bits, upper 20 bits, into register 30, a temporary register, then OR them together. That's how I can actually bring in or set a 32-bit immediate value in a RISC-V processor. There are other ways if you have smart linkers, but for our case here, we're just going to use, assuming that we don't have a smart linker. Now, I'm just going to build up a second test word. And now we're going to start creating 2 addresses to store data and then show you how to view those data in memory through the memory view option. Now, the first one I want to show you is if we're using, instead of the load upper immediate operation, which are unsigned immediate values, we're going to actually use the add I, which is using immediate, assigned immediate value. Now, if we take a look at this as I step through this, we load a 1, then we move it up 12 bits because I want to create the address 1F70. So my lower 12 bits are going to be F70. Now, if I use the add immediate, and since the add immediate is a signed operation and the 12th bit of F70 is a 1, you can see my register 18 here, then instead of F70, I have all my upper bits are all 1, and so it's not what I expected it to be. Well, I should say, if you remember it's a signed operation, it is what you should expect, but it's not what I want, which is an F70, assuming my next operation is an OR. So you can see that the value that I have in my address is not what I want. Well, if you know that your address memory location is less than 20 bits, you can just do a load upper immediate, and then just shift it down 12 bits to the lower locations, and you got your memory address or your immediate loaded into your register. But many times you don't know where that register is. It could be lower 20 bits, it could be upper 20 bits. You might have it at assigned immediate. So really, the best way to always load an immediate operation is to use the 4 steps where you're going to use 2 load upper immediates, a shift, and an OR, like I showed you previously. Now here's an example where the linker is going to help us out. We have a label called data, and it's down here. And so the linker is going to take the address of data and it with 3 Fs, and that is going to be our load upper immediate. And then we're going to, so we'll scroll down past that instruction. You can see that I have a value of 7C. And then I'm going to shift it right 12 bits like I did previously, loading my test data in. Now, our linker is going to help us again. It's going to just grab the upper 20 bits of our data and then shift it to the lower 12 bits because that's where I need them in the immediate for my load upper immediate operation. So once again, I'm using a register that I don't have a view right now set up for. But then when I OR them together, you can see this is my address for data. Now we're going to store the first test value in 17, which is 1F70. And then we're going to also store my second test value in the address plus immediate, which is 4. So I can validate that in memory by going to the memory view, clicking on my selection. And my first way of doing it is I can just give it a hard address. Select return. Scroll down. It's going to give you some memory range above and below your target memory. So this is my first test word that I showed you. It looks just like the register. So register 10 plus 4 right here. So we have set up the rendering view right now for Codasip Studio for this class. As the default is word. It's a word representation with Little Endian, which means the smallest byte will actually always be on the right. So as we look at this, the 0 byte is actually going to be on our first word to the right. Then we got byte 1, byte 2, and byte 3, byte 4, byte 5, byte 6, byte 7, because we're representing words so that they look exactly like your register file. Now, let's take a look at this other store operation. I'm going to store my first test byte or word in address at 16, and my second one plus 8. Now, I can also specify memory locations by giving it a range. So let's go OX1060 to OX1090. So here's my range, which I specified, and you can see here, here's my first test byte at address 107. This is 8, so this would be Charlie, which is my first address. And this would be 1084, which is 12 plus 8, which would be a 4. So you can see how I can actually view my store operations in memory using the memory view, using the word memory rendering with Little Endian specified. Now, if you want, you can always delete your memory views in the debugger by clicking delete. You can just specify one, or you can tell it to specify all of your settings and then hit delete. Hopefully this video helps. If you like this video, please subscribe to this channel so you can be updated when new videos are published, and good luck.